we have two solid spheres of identical shapes. That is, both of them, they have a radius equal to r, but their masses, one is of mass m, the other is of mass 4m, and their centers, they are separated by distance 6r. From the surface of this sphere, a small mass m is projected with a minimum velocity v along the line joining the two centers of these two spheres so that it reaches the surface of the other sphere. We are asked what is the minimum velocity v that should be given to this mass so that it reaches the other sphere. We know that is along this line joining the two centers of these spheres, there is going to be a point which is neutral point at which the net force on this mass m is going to be equal to 0. At the neutral point, this mass will be pulling it this way with the force Fa, and this will be pulling this mass m with the force Fb in this direction. There is going to be instant, that is what is a neutral point, where Fa is going to be equal to Fb, that is net force is going to be equal to 0 onto this mass which is moving in this direction. On the left side of neutral point n, the pull of this sphere is greater as compared to the pull of this sphere on the mass m. Beyond this point, let's say towards right of this neutral point, the pull of this sphere is going to be stronger as compared to the pull of this sphere onto the mass m. So n is the neutral point where Fa is equal to Fb. When we say what is the minimum velocity that should be given to the mass m from its surface so that it reaches over here, it means primarily we are talking about that is what is the minimum velocity that should be given to mass m so that it is just able to overcome this neutral point, so that it is just able to pass this neutral point. So once it passes over this neutral point, then certainly it is more in the territory of this sphere, and after that the Fb is greater than Fa, so it will easily accelerate and will reach this sphere. Let's find what is the minimum velocity that is required to just reach over here. For that, we have to first find what is the neutral point, that is where is the neutral point with respect to the center of these spheres. Let's take it at a distance x from this center. Total is 6r, so distance from this center is going to be 6r minus x. This is the neutral point, so over here Fa is going to be equal to Fb, that is neutral point where Fa is equal to Fb. So gm upon x square over here, that is the force of attraction between this and this, gmm upon x square, this distance we are taking as x, should be equal to the force of attraction between this and this mass, that is gm, mass is 4m into m, this is the mass m, upon the distance between the two, that is 6r minus x into square. So when we solve it, the x comes out with 2r. Now, if we use the conservation of mechanical energy principle, first we find what is the total mechanical energy when this mass is over here, and then we'll say what is the total mechanical energy when this mass reaches the neutral point. We'll equate the two, and from there we'll get the equation. When it is over here, position number 1, that is at the surface of this sphere, then over there, minus gm upon r, that is the gravitational potential energy between this and this, it is what? Minus g mm upon r. Gravitational potential energy of this and this is what? If the distance from here to here is r, total is 6r. So at position number 1, the distance between this mass m and the center of this sphere is 6r minus r, that is 5r. So gravitational potential energy of interaction between this and this mass is minus gm, that is 4m, m upon 5r. So this is the gravitational potential energy between this and this, this and this, and also it has been given a velocity. It means the kinetic energy also has been given, that is half mv square is going to be when it just reaches over here, that is neutral point. Over here it just reaches over here, we assume that is its velocity is just equal to 0. It has just reached over here. When the velocity is just equal to 0, now the gravitational potential between this and this is minus gm upon x. X is the distance between the two, which is obviously equal to 2r, we have calculated, plus the gravitational potential energy of this and this, that is minus g 4m m upon 6r minus x. We can put the value of x over here, 2r, plus the kinetic energy obviously over here, that is equal to 0. That is what we have done over here is we have just equated the two total mechanical energies. Initially it is this when the body has just been projected from here, and the second is this represents the total mechanical energy of this when it has just reached the neutral point. So from here when we equate the two and we solve it, we get the value of under root 3 gm by 10r. So this is that minimum velocity which will sufficient enough to just bring it over here. Any velocity which is greater than that will obviously move this body beyond this neutral point, and after that the pull of this is going to be stronger as compared to the backward pull because of this. So any velocity which is greater than this will easily take this body of mass m from here to its surface. So v is equal to under root 3 gm by 10r is that minimum velocity which should be given to this body of mass small m so that this body reaches from here to here.